So we're looking at a scenario wherein we have a pre-existing electrical field and then we are getting the charges. In the last scenario, we had no such thing. So the last derivation had no such thing. So here we have a pre-existing electrical field. We have a charge that will get it over here, say point P, and another charge that will get it over here, point Q. Now, the derivation will start like this. So we are considering a pre-existing charge or pre-existing electrical field. And we are getting charge Q1 and charge Q2 to point P and point Q, of course, from infinity. Now, what will happen? Q1 will encounter a push or a pull because of the pre-existing electrical field. While Q2 will also experience a push or a pull because of pre-existing electrical field, right? Yes, and because of Q1. That's all. So basically 1, 2, 3. 3 expressions. 1, 2, 3 actually. 3 expression if we add up, that would be a total, yes, potential energy of that system. Does it make sense? Right? So a bit of write up and we are done. So as there is a pre-existing electrical field, work has to be done to bring charge Q1 to point P. So we know that work over here is your potential at, in this case, P times of, or potential into, let me do this raw formula first, into charge. So here the work or the energy is equal to the work will be equal to potential at P times Q1 in this case. Now work done in bringing Q2 similarly would be U2 is equal to V of Q into Q2. Right. But the charge Q1 itself will have its own field. So potential at that point would be because of Q1 at capital Q would be K Q1 by R12. So if I call this length as R12, so that's the length. Again, this is nothing but potential because of Q1. It has altered the space, right? So that effect is over here. And thus the work required to get would be U12. We are going to represent that way. K Q1 Q2 by R12, right? Just multiply similar to this, right? Potential into charge. So we have the potential expression. We're multiplying the charge that we are getting in. And finally, what should we end up with? So by principle of conservation of energy, all the energy that we have spent, the total potential energy in the system, let me write that off. The total electrical potential energy. Actually, you don't have to write it as capital. Electrical potential energy of system would be equal to what, guys? Sum of all of that, simple as that. So U is equal to U1 plus U2 plus U12. So this is, I hope I'm right regarding this. Yeah, I think Q2 plus K Q1 Q2 divided by R12. That's it. Simple as that. Okay, guys. So now you can pause, have a look.